addition. You can also think about subtraction because pretty much it's the same. Subtraction of vectors in 3D space, right? Now, once once we have the Cartesian components of force vectors. So first step is you decompose all of your vectors into their components along XYZ axes. Right? So you find out the Cartesian components of those vectors. Once you have those, the resultant vector, remember resultant, we said resultant is basically the result of addition or subtraction. The resultant vector's components is basically their scalar sums of the components along these three axes. That's it. All right. So let's put it this way. When after finding the Cartesian components of two or more vectors, the resultant vector is the scalar sum, write it this way, of I, j, and k components, I, j, k components. And that's pretty much it. Now, you can think about, for instance, two vectors. For instance, for two vectors, right? Let's say vector A has components of axi plus ayj plus azk. Right? Components ax, ay, and az are just components along xyz axes. And B is bxi plus byj plus bzk. Just these two vectors. And the resultant vector, very straightforward. Resultant vector becomes, we just do the scalar operation. Ax is just a number, b is a number. It can be positive or negative. So this is a plus b becomes ax plus bxi, right? Plus ay plus byj plus az plus bzk. Right? That I do have a picture, I think, from the textbook, or maybe a similar textbook that covers this topic. There you go. Might give you a better sense of what am I talking about here. So if this is A, right, you see A and B there. If this is A and this is B, you can see that the whole triangle or parallelogram law, it still applies in three-dimensional space, but we actually cannot do it that easily. So what happens is that the R resultant has components, that those components are basically the vector sum of the components of the other two vectors. And these components, this is Rx, this is Ry, and this is Rz. These components define the resultant vector R. All right. So if you have multiple vectors, you can just write it in generally. If you have multiple vectors, in this case, like we are talking about forces. So this is a summation of forces. much. And if you can expand this, saying summation of forces in x in I direction plus summation of forces in y in j direction plus summation of forces in z. And by force, I'm talking about vector f. Since we mainly talk about forces, I'm just referring to it as force. But generally, it's just vector. Right? So this is what boils down into the whole thing. So represent the vectors in Cartesian coordinates. Once you know I, j, k components along these three axes, sum up those components, whether they're positive or negative, or you might add them or subtract